Hello all, and welcome to my Physics 2211 Lab Number 2 presentation by myself, Sakir Amdan. To introduce you to the lab's goals, we're supposed to observe the motion of some object that is released from a certain point. We're going to use Newton's second law to predict the position of the object at various times. We're going to use Tracker to observe the object's location at time intervals and create a computational model using GlowScript to simulate the object's position. Then we're going to make comparisons between the experimental model and the two computational models, one that assumes no drag force and one that assumes a drag force, and both assume a gravitational force. Some key concepts of lab. One is velocity, which is equal to displacement divided by the change in time. Another key concept is Newton's second law, which is that the net force is equal to the sum of all forces. And there are two forces on this system, gravity and drag, and they point in opposite directions. The gravitational force is mass times gravity, and the drag force is b times v squared, where b is the proportionality constant. And we determine this experimentally using GlowScript. The velocity update formula and the position update formulas are also important concepts for the while loop instead of GlowScript. V final is equal to V initial plus F net divided by mass times delta t. And the position update formula uses that velocity update formula. The R final is equal to the R initial plus that average velocity times delta t. So initial values and assumptions, I dropped a mask which had a mass of 4 grams and was 15 centimeters long. I assumed that motion occurred in the negative y direction and that the only two forces acting upon the system are the gravitational force and the drag force. And a caveat to my data was that the tracker position data was slightly off for the first few measurements. Movement was not observed until 0.1 seconds into the video, and that the coefficient for the drag force was 0.011, which again was determined via GlowScript. So here's the tracker data. I set the bar as approximately 1.5 meters, and you can see the mask fall. And then I had about 28 time points, and I used that data for my analysis. And then here I have my GlowScript code. So this is the one with no drag. We have the position entered, the velocity was 0 because it was dropped, and then we have the two update formulas. Then when we run the program, we can see that velocity is constant and that the final position is actually through the ground. That's at -3 meters. And then here we have the one with drag. We have to update the drag force here by finding the magnitude of the velocity and then finding the proportionality constant and then squaring that. So here we have a more linear graph near the middle and near the end, because the velocity graph we can see bottoms out near -1.76 meters per second squared, or -1.76 meters per second. And then I imported this data into Excel so I could graph it. And we can see that the tracker data and the model with drag were pretty similar, and that the model without drag was very different. We can see that it continues to drop rapidly, and it's a bit of nonsensical data because we know that the final position cannot be through the ground. So you can't have a -1.5 meter final position because that does not accurately simulate the data. So I can go to the what does it mean slide. Terminal velocity occurs when the velocity is constant, and the model with drag showed a terminal velocity of -1.8 meters per second. The model without drag does not show a terminal velocity because the velocity graph is linear, and because velocity is constant, there's no net force when there is a terminal velocity. Thus, the drag force is equal to the gravitational force at that instant. So what if it's thrown downward? If the object is thrown downward, then there is a negative initial velocity. This does not affect the terminal velocity because the terminal velocity is the upper limit of velocity and is only affected by the proportionality constant in gravity. So I can go back to the tracker data and edit the program with drag. I can put in a -10, say, as the initial velocity, showing that it's thrown down. And as I run the program, we can see that the initial velocity is the same, and then we drop down, and this terminal velocity is the same at -1.76 meters per second. So the initial velocity does not affect the terminal velocity. All right, thank you for listening to my presentation.